Okay, thank you, Yanqi. This was a very nice talk. And we have someone with a raised hand. Let's start with Sujaniya again.
Hi, Yanqi. Thanks for a great talk. So I have a quick question about how the applications have to change for tolerating either bounded failure or live and let die scenarios that you mentioned in your system. Do you expect applications to have some sort of reliability, crash consistency or reliability model, or does the system itself handle it?
Thank you for your question. So what we hope for the application is that it should have the same guarantee as the original kind of applications, since even in a normal workflow, in a normal like source framework, you would also have invocation failure caused by like underlying VM failures and such things. And in that case, since we do not require any source code changes or any like platform or framework changes to run the things on Harvest VMs, this invocation should be safe to go without modifying source codes. And as long as they have the same reliable guarantee that are provided by the framework itself, they should be reliable. Yeah.
So do you assume these applications originally are running either on dedicated VMs or on spot VMs?
So I think for now, most of the service workloads are run on dedicated VMs. And that's
yeah, in those cases, applications might not be seeing as many failures, or they might not assume that the dedicated VM would be taken away, right?
Yes, exactly. You have more. You definitely have more failures if you run on Harvest VMs. But even if you run on regular VMs are not safe all the times. They can also be evicted and they can also fail. And the framework, we also design a kind of recovery mechanism for this kind of workloads, even if they run on dedicated VMs.
Thank you.
Mm-hmm.
Thanks. So next up, we have Edward.
Hi, so this was really interesting. It's really cool to see that even by just using live and let die, most of the time things don't fail. But I wondered if you could give a little bit more detail on that load balancing algorithm. You said I got the intuition by why you want to avoid cold starts, but I didn't really understand why your new algorithm was able to avoid cold starts and also keep the load balanced.
So sure, yeah. So for if you start to think from join the shortest queue, and in the case that you have thousands of machines, and in that case, if you want to pick the machine with the VM with the lowest queuing latency or the shortest queue, in that case, it could be any one of the machine in your system. And in that case, for each application, the invocation of the application could be spread across all the machines in the system. And in that case, that will enforce each invocation to be a cold start. What we're trying to do is that we consolidate all the invocations of the same application to a very small set of machines. And in that case, the interval time between these invocations are pretty short, and so that we can safely reuse the containers that we created before.
Okay, so and I assume you have some algorithm for deciding like the pool of servers that you should allocate to an application. Is it based on its expected running time or expected load?
I think that's a capacity planning problem. And in that case, I think probably when you try to provision the cluster, you should probably want to look at, as you mentioned, the execution time, the resource requirements, and the RPS of all the workloads, and see how much a cluster you want to provision for a peak load, and so on and so forth. Yeah.
Right. So you have to do a little bit more advanced capacity planning than just send VMs to the shortest queue, but obviously it's a lot better for their start times.
Yes. Yes.
Okay. Thanks.
Thank you. Question from Marcin.
Yes. Thanks for the very interesting talk. The one thing that I'm still not certain about, maybe I misunderstood the presentation correctly, is you show a much improved throughput towards vanilla open risk. And what is the main source of that? Is it caused by the fact that you have more resources and you can keep more containers alive to suffering fewer cold starts?
So I don't know if I heard your question clearly. So are you asking that like why can we reduce co-stars with our new algorithm?
No, so what is the main source of this improved throughput when compared to native vanilla OpenWhisk?
Oh, well, compared to vanilla OpenWhisk, there are two sources of improvements. The first one is from resource harvesting. Since we run harvested resources, which are much cheaper than dedicated resources. So under the same cost budget, we can afford to buy more VMs to run our framework. And with more VMs, with more resources, you definitely get more performance. That's one. And the second, compared to vanilla OpenWhisk, which deploys a pretty straightforward load balancing algorithm, we try to reduce co-star based on that. And especially for these short running functions, co-star can take a very high fraction of the entire execution time. And in that case, we can also improve the performance of the latency with the new load balancing algorithm.
Okay, I see. So basically, for both reasons, this comes from the fact that you have more resources, so you can run more, and you can basically have more warm containers.
Yeah.
Okay. Thank you.
Mm-hmm.
Cool. Thanks. Next question from Saurabh. Hey, Saurabh.
So my question is regarding the comparison of harvest VMs with spot instances that you showed.
Mm-hmm.
So quantitatively, harvest VMs are very different, as you showed. But I wonder if the same strategies, maybe with different parameter settings, will be useful for running serverless and spot instances as well. And as economic drivers push the price of spot VMs down, is the difference going to reduce between harvest VMs and spot instances?
Yeah, that's a very interesting question. So yeah, I think the methodologies that we presented should also be applied to spot VMs. And also, as you mentioned, one of the benefits for harvesting is that it's cheaper than spot VMs. And yes, if spot VMs also become cheaper, then it's definitely like lose. So definitely harvest VM will lose some of the benefit on the perspective. But from another perspective, harvest VM also tend to be more reliable than spot VMs since it is more like flexible. And since spot VMs are fixed size, when you have on the same server, when you have a high priority VM that comes in, some of the spot VMs might need to be evicted, and all the workloads running on the spot VMs have to be killed. But with resource harvesting, the harvest VM just need to shrink some of the size to make more room for the high priority VM, as long as its base size is not needed. And I think in our paper, we also show that the reliability of the harvest VMs is orders of magnitude better than the spot VMs. And I think that's the cause of that.
Thank you, Yanqi.
Mm-hmm.
Cool. Thanks. And question from Chirag Shetty.
Yeah. Hi, thanks for the talk. So I had a related question comparing spot VMs and this. Spot VM, definitely harvest VM seem to be better from a service provider perspective compared to spot instances because you're able to fit it better, etc. But in terms of the user, right? What are some, as in, because users are usually binary, right? I either need reliability, more, less reliability, mom and pop users. So are there any examples from your studies, for example, where you say, look, this application couldn't have been used in spot instances, but you could probably use if you're using harvest VMs? Or is this only a perspective from the service provider side, the difference between harvest VM and spot VM?
Yeah, that's an interesting question. So I would say that if you compare harvest VMs to spot VMs, harvest VMs are always generally safer and cheaper, and the challenge that it really introduces is that you might need to deal with the resource variation that originates from this resource harvesting. And if you have some workloads that are hard to take advantage of this kind of resources that are flexible added to the harvest VM by harvesting, then this kind of workload might not be able to benefit from harvest VMs. But as long as your workload is able to and leverage the additional resources, especially CPU, that are provided from harvesting, then this kind of workload should be more beneficial to be run on Harvest.
Yeah, got it. Thank you.
Thank you.
Thank you. Ashraf Mahmoud.
Hello, thank you for the great talk. I had a question regarding the selection of the VM size. So most of the serverless platforms ask users to select the VM size for their functions. I was wondering, with using Harvest VMs, do users still select like the minimum acceptable VM size for their functions? And would this kind of impact their minimum latency that could happen versus the probability that they get evicted? Like if they take a bigger VM, they guarantee at least this number of CPU cores, but there's a higher probability for their function to be evicted.
So for the VM size that we're using in the experiment, in general, we want to choose a small Harvest VM size, since the smaller size translates to a lower cost for the base resources. Since base resources are always this kind of the preemptible cores are always like more expensive than the harvested cores. And in that case, we always want something to be smaller, as long as we have enough memory to pack all the containers that are scheduled onto this VM. And I think for serverless workload, at least for OpenWhisk, you do not need to specify the VM size that you want for the application, and you only need to specify the memory size for the application you're running. And that's also like one of the philosophy for serverless frameworks. We want it to be mostly infrastructure agnostic to users, and users only need to submit their codes and specify probably some resource requirements without looking at the VMs management or the infrastructure stuff.
Thank you.
Well, thank you so much.
All right, thank you. We have time for questions. You can either raise your hand, or if there are questions on Slack, I can read them out. But I keep missing Slack messages. Okay, go ahead. Someone raised their hand. Sorry, I missed it.
Yeah, so that was me. Maybe I can try asking a question. Thanks for that talk, Bianchi. That's a pretty great talk. I have a quick couple of questions. Maybe I can ask them both one at a time. If someone else has a question, you can interrupt me. The first question I have is basically, in terms of the economics model, do you expect the, so like there's already like spot instance counterparts where the cloud providers offer these spot instances at a cheaper price. Do you expect like a similar form of like spot serverless functions appearing as a consequence of this being deployed on harvested VMs, which are cheaper and they can actually translate the cost benefits to the user?
So yeah, so thank you for the question. So yeah, so definitely like for spot VMs, there are also another alternative kind of VM that can provide a cheaper price, but like a less reliable alternative compared to regular VMs. And yeah, we can also deploy a similar mechanisms on spot VMs to get also a cost saving, both for users and for providers. Since we have a naturally cheaper service product, it's more like a financial decision to decide how much cost benefits should be given to the users and how much cost benefit should be given to the providers. And also Harvest VMs are better, at least in our case for serverless workloads, is because like most of the time harvested resources are cheaper than spot VMs, and also because Harvest VMs are less likely to be less likely to be evicted. So they are also more reliable than spot VMs as a alternative. And also this can also be the case for most of the workloads, since that like your Harvest VMs are usually more reliable and they have more resources under the same cost budget.
Thanks. That makes a lot of sense. So I have another question, but I want to make sure nobody else has one and not blocking anyone. Okay, I'll ask another question. So the second question I had was, despite the fact, I think Patrick has a question, but I'll just quickly finish mine. So one of the things that you observe in the paper is that these harvest VMs are more reliable in terms of sticking around for longer, and therefore they have lower evictions. But you still don't have control over the harvest VMs the same way you have control over the dedicated VMs that you use for traditional serverless hosting, right? So does that kind of make it tricky for you to maintain functions that are warm? For instance, if I have periodic repeats of the same function being executed over and over again, cold starts can be a performance issue. So given the fact that these harvest VMs could be evicted, unpredictably, do you ever face issues around cold start latencies?
Yeah, that's an interesting question. So in general, I tend to think that actually using harvested resources would actually improve the cost. Could improve the warm start rate for serverless workloads. And the reason is that under the same cost budget, you can afford to have much more resources than the dedicated resources and then dedicated VMs. So in that case, the system can actually cache more warm containers compared to dedicated resources. And thus it's more likely for an invocation to find a usable container instead of creating one from scratch.
I see, that's super interesting. Okay, thanks. Thanks for that.
So I guess Patrick had a hand up.
Yeah, I do have a question. It's more of a general question. First off, thank you for your presentation. I enjoyed it. So the question is there any reason why you chose to use OpenWhisk as your platform to conduct your implementation, as opposed to some other open source serverless platforms like OpenFaaS? And the second part of the question is, when you were modifying OpenWhisk for your implementation, were there any issues that you faced? Yeah, thank you.
Yeah, thank you for the question. So the reason that we adopted OpenWhisk was mostly because it's kind of like a open source tool that were built by by industry, and it almost has all the features that we when we started the project, it almost had all the features that we wanted, especially for typical serverless workloads that you can imagine. Something like most workloads are short, and you can put a runtime limit on this kind of functions, something like 5 minutes or so. And in terms of modifying OpenWhisk, well, I think for me the biggest issue might be that it uses Scala, which is not something that I used before. So I need to learn a new language for that. Yeah.
Thank you. I appreciate it.
Mm-hmm.
All right, thank you. Any other questions for this paper?